So hello everyone. So today we are going to solve a basic inventory system problem in MATLAB Simulink. So let's get into the problem. The problem goes as design and implement a Simulink model for a basic inventory system. The inventory system starts with 50 units. So let's keep the initial inventory value as I1. So the value of I1 is 50 units. A random demand between 1 to 5 is generated. So we have a demand. Let's keep the demand as D. The demand is between 1 to 5 is placed. And the inventory falls below or equal to 20 units, it should be restocked. So the condition that we are given is if the inventory falls below or equals to 20 units, it should be restocked, which means after demand the value of inventory will be I2. So if the inventory is greater than 20, then there's no problem, the inventory can go on. However, if the inventory value falls below or equals to 20, the inventory should be restocked, that is it should be restocked to 50. And what you need to basically know here is the value of final inventory is given as initial inventory minus the demand. So we have an initial inventory of 50 units, and when we subtract the demand from the initial inventory, we'll get the value of final inventory. So this is the basic concept of this problem, as well as this is the basic mathematical of this problem as well. And most importantly, the final line of the problem mentions that the model should prevent negative inventory values. That is, whenever the demand is subtracted from the initial inventory, the inventory should not fall below 0. That is, just imagine you have a box and you have 50 numbers. You remove all the units from the box. What is the least value that you can have in the box is, it's obviously 0. You cannot have negative values or negative units in an inventory or in a box. So this is the concept. So we need to make sure that the model should prevent the negative inventory values. So this is the problem and this is the mathematical model. Let's jump into the Simulink workspace. So we have a workspace here, and let's begin. So to initially start with our initial inventory value, I'm going to use a memory block. So this memory block, if you don't know where to find a particular block, just type the name of the block in the search term. I'm going to type as memory block here, and when you click enter, Simulink searches you and gives you the blocks. So this memory block is what we are going to use for our initial inventory. So double click on the block and set the initial condition to 50. So rename this block as initial inventory, and then we need to produce as per our question, we need to produce a random demand of 1 to 5. So to produce that, I'm going to use a random generator block. So this random generator block is found in Simulink sources. So under the sources, you can find this random generator. So you have two blocks here, random number as well as uniform random number. I'm going to use a uniform random number because if we use a random number block, we cannot monitor the values between, or we cannot control the values that the block generates. However, in uniform random number block, you can control the values or the range between which the uniform values should be generated. Just double click on the block and you can see the minimum and the maximum value. So for minimum value, I'm going to input as 1, and maximum value as 5. Click OK. So now we have a demand as well. So now as per our concept or logic here, the final inventory value is initial inventory minus the demand. So to execute this subtraction, I am going to use a subtract block which is found in math operations area. So in math operations, you could find a block called subtract. Here it is. Just pull it here, and I'm going to connect the output of initial inventory to the positive port and the output of uniform random demand to the negative port. So let's just rename this to a random demand block. So now we have a final output. So like mentioned in the question, this model should prevent negative inventory values. So to prevent that, we are going to use a block called saturation block. So just type it here and press enter. You'll find the saturation block here. So drag the saturation block inside the workspace. Now double click on the saturation block, you'll find the options of upper limit and lower limit. So what its saturation block essentially does, it limits a particular input between a particular values. It does not allow the output of a particular block to be beyond or to go less than certain values. So upper limit, I'm going to keep it as something greater than 50. Let's keep it as 100. The lower limit, I'm going to keep it as 0 because I should not get any values less than 0. Click OK. And now we are going to connect the output of final subtraction block to the saturation block. So this saturation, now we have a final inventory values. So now let's jump into the conditions. So as per our question, the condition is the inventory should not fall below or equal to 20. If it falls, then it should be restocked. So to ensure that, for conditions, I'm going to use switch block. So switch block is essentially found in the signal routing option. Just get below. You'll find the switch block here. So in the switch block, what the problem, basic problem, particular problem with the switch block is the criteria here are only 3. So one criteria mentions that it should be greater than or equal to, another criteria mentions that it should be greater than, and another criteria it simply says that it should be equal to 0. But what we need is, we need the value should be less than or equal to 20. So for that, I'm going to use another block which is known as compare to constant. I'm typing the name of the block here, compare to constant block, and click enter. Here you can see a block, the compare to constant block. I am pulling the compare to constant block inside the workspace. So by default the value is 3. Double click on the value and change the value as 20. And check the sign here. The sign here tells us that it should be less than or equal to 20. So let's just connect the output of the saturation block to the compare to constant, and in the switch block the middle port shows that the middle port signifies the condition. So I'm connecting the output of this compare to constant block to the middle port. So now we have a condition here. So if the condition is satisfied, the inventory should be restocked to 50. So I need to add a value of 50 here. So for that I'm going to use a constant block which is found in the commonly used block. So put a constant block inside, double click on the constant block and enter the value as 50. Now rename the constant block here as restock. So if this condition is true, then the value given in the upper port will be satisfied. So I'm going to give this value as 50. However, if we know, like if the inventory does not fall below 20, the inventory value can go on. So I'm going to do is I'm going to branch this final inventory here and give it into the third input. So to branch the signal, just right click on the signal and pull it. See, now I'm going to give it as input to the third one. Now we have it here. Now once this process or condition is completed or it is restocked, the initial inventory value should be updated, right? So I'm going to do what I'm going to do is I am taking the output of this switch block and connecting it to the initial inventory block. So by this way, this inventory system is continuously looped. That is, whenever the value falls below 20, the number 50 units are restocked. And if it is not, it keeps on going. So we have completed our basic simulation. So now to view the result of this, I am going to use a scope block. So pull a scope block from the commonly used block. So to know, so what I need to view is I need to view this output of the switch block. So I'm branching this here and giving it as input to this scope block. So that's it. That's complete. Let's run the simulation. So the simulation is completed. Double click on the scope block and you'll see this graph. So what this graph essentially tells us, we have a basic inventory. A basic inventory value starts from 50, and once the demand arises, the inventory value goes on decreasing until the value reaches 20. However, when the value reaches 20, the whole inventory is restocked to its original value of 50, and again this process continues and it goes on. So this is the output, or this is how we interpret what we interpret from this graph. So hence this is a final simulation of basic inventory system in MATLAB Simulink. Thank you guys.